Today, actually, we are going to explain lesson 4.1, or we're going to review 4.1 for the examples and for the key concept as well. Starting from classifying triangles by sides, scalene triangle, non-congruent sides for this one, scalene triangle, non-congruent sides. So, which means actually there is no one of the sides is equal to the other. So this one is, for example, 5, and the other one is, for example, say 3, and for the last one, for example, equals to 7. This is the meaning of non-congruent sides. Concerning the other kind, classifying triangles by sides, the second kind is isosceles triangle, which means two sides only equals or congruent, at least two congruent sides. The third kind, equilateral triangle, three congruent sides. So this one is 5, the other one is 5, the last one is 5. Let's go to classifying triangles by angles. We have four kinds. The first kind is acute triangle, which means three different acute angles or three acute angles in one triangle. For example, 50, and the other one is, for example, 60, and the last one is 70. So this kind of triangles called acute triangle. The second kind is right triangle. So it's very clear, one right angle, which is 90 degrees for this one. Third kind is obtuse triangle. Obtuse triangle means this angle is greater than 90 and lesser than 180, which is one obtuse angle in the kind of obtuse triangle. Finally, the fourth kind is equiangular triangle, means 60, 60, 60, so they are all congruent, three congruent angles. Okay, let's go to the example number 1. How can we solve example number 1? Example number 2, I'm sorry. Example number 2 is classify a triangle in a coordinate plane. Classify triangle PQO by its sides, then determine if the triangle is a right triangle. Okay, so you have two parts in this question. The first part, you have to prove its sides, and the second part is you have to determine if the triangle is a right triangle. So we have two rules concerning to prove or to determine actually the sides of this kind of triangles. Sometimes they are giving the triangle drawn for you, and sometimes they are asking you to plot the points and graph it yourself. It doesn't matter at this point, but if you are asked actually in a question to solve the sides or to find the sides, so you have to follow the rule of the distance formula, which is this rule, distance formula. Okay, so first of all, actually, we are going to find OP. Where is OP? OP, the points of OP. We're going to find the points. First of all, you have to label the point x1, y1, x2, y2, and then you have to plug in the numbers in the rule. For example, x2 is 0. Let's make it here. 0, x2, we are finding OP. It doesn't matter if you're going to flip the points in the question, they flipped the points, they are flipping it, so no problem. Anyways, we can make it like 0 minus minus. So the first point is x2, 0, and minus minus equals to what? Equals to plus 1 whole power 2 plus much better to make it like the textbook. Okay, I don't want you to get confused. Okay, it doesn't matter. Make it like the textbook. I'm gonna flip the points. Make the points. Okay. So we're gonna make this point x2, y2, x1, y1 and plug in the points like in the example. It doesn't matter, by the way, if we're going to flip the points or flip the rule, like x1 minus x2 all power 2 plus y1 minus y2 all power 2. It doesn't matter under the root. It's the same, by the way, the same answer as well. In this case, minus 1, which is between two brackets, as I said before, minus 0 all power 2 plus 2 minus 0 all power 2. The answer equals to root 5 or radical 5. Leave it radical 5. Okay, for the second one, it's OQ. So I'm going to plug in the points for x2. You're going to make the points like erase this one first. And we're going to repeat this again for so in this case, we're going to make it like where is x1 and x2. This one, we're going to make it xq. So for this point, this one is x1, y1, and for this one, q, x2, y2. So we're going to plug in the numbers. The coordinate here in x is x2 is 6, so 6 minus 0, because the other point here for x1 is 0 as well, so 6 minus 0 for this point, 6 minus 0, and the other point 3 minus 0 equals to radical 45, and for the last side length equals to root 50 or radical 50. Okay, this is the first part actually from the question. He's asking for the sides. Concerning to prove the right angle, the other part from the question, you're going to use the slope form, which is m slope equals y2 minus y1 over x2 minus x1. So you're going to do the same points, and you will prove, actually, you will find the answer for each slope. For example, OP, the slope of OP equals to -2. The slope of OQ equals to half. So you have to remember the rule of the perpendicular, which is you have to take any kind of values. For example, OP equals to -2. So how can you make it like perpendicular? Okay, or 90 degrees or normal or whatsoever. So you have to flip this answer first, make it 2 steps. The first one you have to flip it, and then the second point you are gonna change the sign. So it's gonna be 1 over 2. In this case, -2 for the two conditions I have to pass concerning the perpendicular. So this one is a right triangle. Okay, question number or example number 4. Example number 4, actually we're going to use the theorem of example number, let me check first. I have this example and the other example. Okay, I'm sorry. We're going to do this example, example number 3. We have a theorem, exterior angle theorem. If you have angle 1 equals the exterior angle equals angle A plus angle B. This is the theorem. Okay, example number 3. Find measure of angle JKM. So he is asking you to find the measure of this angle, which is 2x minus 5. First of all, I'm going to apply the theorem first. So 2x minus 5 equals to x plus 70. Okay, we're going to move the -5 to this side. and we're going to move the x to the other side. So 2x minus x equals to 70 plus 5. Okay, x equals 75. We didn't solve it till now, okay? You have to plug in the value of 2x in this angle, so 2x minus 5 equals to 275 multiplied by 75 minus 5, so the answer equals to 145. Okay, example number 4. In this case, we're gonna use um, the theorem of sum the triangle sum theorem. Actually, any kind. If we have a right triangle, we have a triangle like this one. Okay, so it's 90 degrees. So the rest of the two, or if you are going to add the two angles, the other two angles equals to 90 as well. So if you have like this example or this theorem, so we're going to use it in this example, example number 4. We have a triangle in a staircase. Shown forms a right triangle. This one is 90, and one of the angles 2x, and the other angle equals 2x. So in this case, we're going to say 90 equals 2x plus x. So 90 equals 3x divided by 3 divided by 3. 90 divided by 3 equals to x equals to 30. If he's looking for an angle, okay, so the 2x equals 2 times 30 equals to 60, and concerning this angle, x equals to 30 directly. So if you're going to add 60 plus 30 equals to 90. Okay, we are going to take another example. One of the examples. Let's take a look about any kind of examples. Let's make it together. And this is going to be the review for lesson 4.1. I'm going to take this example. For example, let's do this one. Number 17. You're going to make it like x plus 45 equals to 2x minus x equals minus 2, I'm sorry. So we're going to move the 45, leave the 45, move the x to the other side. So 2 plus 45 equals 2x minus x. So in this case, you're gonna make it like 2x minus x equals to x. So make it here x equals to 47, and then you are going to plug in the value of x. So in this one, so 2 times 47, all minus what? All minus 2, which is going to equal to 2. 2 times 47 equals 94. 94 minus 2 equals to 92. You can check actually if you're going to make this one 45, and for the value of x equals to 47, so 47 plus 45 equals to 92. Okay, that's it.